Hi, I'm Philip Resnik from the University of Maryland, which is near Washington, D.C., and I am very grateful for the opportunity to speak today. So I don't need to start out motivating the importance of mental health as a problem. But one of the things that I do want to highlight, though, is that it's not just an important problem, it's one of the most important problems. If you look just at the economic picture, for example, what you find is that mental health as a problem is as large as any of the major problems that we consider to be enormous problems, things like cancer and heart disease and all the rest. So this is a really hard problem. And we are finding that traditional approaches are simply not sufficient. As a concrete example, Franklin and colleagues did an analysis of 50 years of research in the prediction of suicide risk and found that over that time period there has been no progress whatsoever. Now, one of the things that they recommended, and this is a trend, is moving from the traditional approaches to data-driven approaches that take advantage of machine learning. So as one example, Glenn Coppersmith and colleagues did a really nice study using machine learning approaches in predicting suicide attempts. And they found that their system could perform at a level that actually compared favorably to the way that clinicians could perform. Now, one of the things that was interesting about this was they were not looking at clinical data. They were looking at data in what they called the clinical white space. That is the information that you can get in between clinical encounters, for example, from somebody's participation in social media. Another nice example is predicting psychosis. Corcoran and colleagues have done some really nice work, also showing very promising results in the ability to analyze people's language, in this case, elicited speech in the clinic, in making predictions of whether somebody was going to develop a psychotic disorder. Now, one can go further beyond just the problem of binary classification. Is somebody in this group, or are they in a control group, for example, and not going to have a problem? Instead of simply looking for yes or no kinds of indicators, one can actually use analysis of the data in order to find categories and subcategories of information. For example, in essays by college students, you can discover automatically categories of data like what you see in blue here, which has to do with social isolation, or in red, which has to do with vegetative symptoms or energy level, or green indicating anhedonia, or the inability to enjoy things that they had enjoyed previously. We actually used a computational method called a topic model in order to see what you could discover automatically from a set of essays like this. And some of the things that came out were particularly interesting. So for example, you would find a category automatically emerging that corresponded to somatic symptoms like hurting and itching and aching and so forth. In addition, though, you could also find things coming out in relation to things like energy level, vegetative symptoms. And what was particularly important here, notice in yellow, there are words and terms here that are emerging specific to this population. College students are talking about things like being late to class and taking naps, and those are indicators that you might not find in other populations. So I'm going to steal a concept here from Rebecca Resnik, who has introduced the idea of the language sample by analogy with a urine sample, something that you do routinely as a part of primary care. The idea here is that you have a valuable indicator with lots of dimensions that you can pick up from a single sample. And one could imagine using the language technologies, like the ones that I've given you an overview of, in order to discover indicators or dimensions corresponding to the things that you find when you do a urinalysis. So for example, one could look at Gallenker's suicide crisis syndrome and the categories that are relevant in that determination. These include things like state of entrapment, emotional pain, anhedonia, which we saw indicators of in the previous example, mood swings, insomnia, again, sleep disturbances, social withdrawal. These are all the kinds of things that you can find when you look at somebody's language with varying degrees of sensitivity and specificity, just like you have varying degrees of sensitivity and specificity for the things that you find in a urine sample. So I've tried to argue that there is a really huge potential for us as technologists to help. But there's a catch. What's the problem? Data. Real progress in machine learning and AI is made when entire communities are working on the same problems on large shared data sets. So whether you're looking at labeling images, or you're looking at reducing the error rate in recognizing words, in recognizing your speech as you dictate, or automatically answering questions on the basis of stuff that's been read, in all of these cases, you have large communities of people who have all worked in common on shared data sets, and that's a key to the progress. Now, let's look at NLP, natural language processing. On the left, here's a sampling of some typical data sets that have been used. And what you need to notice here is the size of these data sets. In machine translation, millions of sentences. In email, for all sorts of social science analysis, millions of email messages, millions or billions of tweets. It goes on. Now look on the right and notice that these years are not that far in the past. The state of the art for trying to do natural language processing on clinical data and mental health data as well, whether it's social media or the clinical records. We're talking orders of magnitude less available data. Mimic 3 is pretty much the only widely available, really large set of clinical records that people use in doing clinical natural language processing. That is a sample of about 40,000 patients, all of whom were in critical care. So the variety of language that you need to see across specialties, across different institutions that are performing care, across the different ways that doctors and individual patients communicate, all of that is missing. Now, why? Well, one piece of this is that language is hard to fully de-identify. The current state of the art for automatically de-identifying language is conventionally somewhere around 95%. Think about even if that were 99%, take whatever that percentage is and multiply it by millions and millions of items. 5% de-identification failures in a million records is 50,000 errors. That's unacceptable from the conventional standards of what it means to collect data and keep it confidential. So what we have is a situation where legitimate privacy concerns have a side effect. The side effect is that individual researchers and research teams work with whatever data they can find. If you happen to be lucky enough to be at an institution with a medical school or a hospital, you work on a problem based on the data that you have available there. The language is hard to fully de-identify, and therefore we can't simply de-identify it and get it out there like all the other data sets that people are working on. And so what happens? It's just easier to work on something else. Smart graduate students, smart researchers are very happy to go where the data is and work on other problems that will get them a nice job in academia or at one of the big players in industry that do AI research. So what are some things that people are doing as a step toward trying to make progress here? One is taking advantage of publicly available data that often has signals that are kind of a proxy. For example, on Reddit, which has anonymous posts, if somebody posts on the Suicide Watch forum, that might be an indication that they are at risk for suicide. And one could also do other things like have experts label their posts as to their assessment of suicide risk based on what they're seeing. And in fact, at University of Maryland, we've created a data set like that. And because it's anonymous, we've been able to take appropriate steps in order to disseminate that in an ethical way to the research community. Another approach is to elicit donations of data with informed consent from individuals. So Coppersmith's study was done on the basis of data that was collected using ourdatahelps.org, which is a site that's running right now that you can use to go and donate your social media data or the social media data of somebody who has died by suicide, a loved one, for example. And this is providing an enormous new opportunity for ethical data collection for important mental health problems. In fact, we've been working with the Coppersmith and Our Data Health's infrastructure at University of Maryland, collecting data in a similar way, in this case eliciting donations from people who are suffering from schizophrenia or major depression or healthy controls. Now, getting the data is only a part of the problem. Another important part of the problem is how do you enable researchers to work on it safely, ethically? One approach to this problem that we've been pursuing is the idea of a data enclave. Instead of disseminating data out to researchers, where you have to worry about how they're going to manage the data, and you're protected just by legal agreements and data use agreements. Instead, the idea is to create a secure computational infrastructure that lets the researchers come to the data. They can log in, they have the ability to work with the data in a safe, secure environment, and the data can't leave. And this provides an opportunity to get large communities of researchers like the ones I was illustrating before, all working on the same data sets. And so that's something that we've been very actively pursuing. So here's some takeaways. One is that unstructured language, whether it is social media language, the language of clinical dictations, elicited language from patients, these have an amazing amount of untapped potential. But there is a data crisis in healthcare. There's an enormous problem with the ability of large communities of researchers to work in tandem on these shared data sets, and that is the way that progress gets made. Part of the problem is that language is different from other data. It's hard to fully de-identify. There's also an enormous amount of variability in language, which means you can't just work with small data sets from individual institutions or sources. If you really want to make progress, you need the large scope and variety of big data. There is a way to collect and share these kinds of data ethically and securely, using public sources, using data donation, and using data enclaves as a way of bringing the researchers to the data so that we can work on this together in the same way that the AI community and the natural language processing community have made progress for decades on problems like machine translation and automatic speech transcription and information retrieval, and the list goes on. The last point I'd like to leave you with is that despite the obstacles that I've pointed out, we are making progress. There is an enormous amount of progress being made in predictive modeling related to mental health. And so I would argue that instead of trying to solve all the problems perfectly, it is beyond time, to start paying attention to what we can do now in real-world use cases that could actually make a difference. And in order to do that, what we need most of all is dialogue, really deep dialogue between technologists and the clinical experts. Thank you very much.